Switzerland to a French audience, they didn't find it funny. Since you're Canadians and supposed to go be bilingual, I wonder what you think.
This is Thermite. It's a powdered mixture of iron oxide and aluminium, which when ignited burns at 2,500 degrees Celsius, which is very, very hot. This is a cup. It's been specially chosen to be destroyed because it's old, it's white, but more importantly, it's French. It's basically used the metal, and well, it's very hard to melt. Lucky then, the brain eggs have plenty of thermite, specially packed into the slow release mechanism of a garden flower pot. The pile on the bonnet directly over the engine block should do the trick. Time to light the fuse and give this homage to French engineering the send-off it so richly deserves. The irreversible thermite reaction begins. Within seconds, the fiery concoction eats through the bonnet, spraying molten thermite into the engine beneath. The devastation continues inside until finally a torrent of white-hot liquid metal pours out of the bottom, signaling the inevitable victory for thermite. A quick check confirms a clear path of destruction through the engine.
Maybe you may think now if Niels is trying to tell us the thermite was used to take down World Trade Center, there's an obvious problem here, because the iron coming out of the flower pot is going through the engine block of the car. This is a horizontal movement. How can you possibly destroy a horizontal column by means of thermite? There is a means to getting around this. The basic idea is all you have to do is put the thermite into a container and it will find its way out of the side of the container. I'll show you a little device which you can buy commercial. What you see now is an advertisement, but it's very short, so I have to tell you what you're going to see. You're going to see the device mounted horizontally, and you'll see two wires coming out from it. It is ignited electrically, and you'll see in front of the little device there's a steel beam or an iron beam, doesn't matter, and you'll see what the little device, the little thermite device does to the steel beam. If any of you has a need to burn down the house while you're on vacation on the Bahamas, this is the way to do it, because it can be triggered long distance. Watch out, it's very fast. That's it. So this is how you can take down vertical steel columns by means of thermite. There are other means of packing and the means of color charges, which I will not have time to show here. Now, evidence for thermite, the thermite has been applied. I've already shown this molten iron was pouring out of the south tunnel. But you also found molten iron in the rubble in weeks after the event. This picture was taken 6 weeks after 9/11, and when they dug into the rubble pile and when they poured out things, sometimes steel beams and columns came along, glowing red and dipping the molten steel from the air. This case, yeah, and I have found witnesses, reports, myself counted 23 witnesses of the cleanup workers talking about streams of molten iron, pools of molten iron, and their boots were burning when they were walking on the rubble. This next picture was taken, also it's just an example, doesn't like, at a time coming up here. This is a thermite reaction from the laboratory to make sure that you get the right associations. This picture, I don't know when it was taken. I had to put it in because what is going on in here? Something completely outrageous is going on in here. This is the thermal map provided by NASA, another scientific institution, who at the time, this is on September the 16th, took an aeroplane and flew over ground zero with an infrared sensitive camera measuring directly the temperature in the surface. So this is a thermal map of ground zero, not a geographical map, a thermal map. And the color code, this is where building the North Tower, the South Tower, and building 7 is up here. And the color code here corresponds to a surface temperature of 750 degrees centigrade, while the temperature up here, and this is the very surface of the ground, was 730 degrees centigrade. This is far beyond what you could expect from an ordinary office fire in the rock. Never happened. And in the intermediate days, in particular, on September the 14th, it had been raining cats and dogs. It has been pouring down showers. And still, you can reach these outrageous temperatures in the surface. This is an official document. There's nothing secret in this. A week later, it had cooled off. But as I told you, when they were digging in the ground, the molten metal was coming out. Many witnesses pulled some molten metal. Of course, it's never seen before after ordinary fires. And it is not mentioned in any of the official reports, this observation. NIST simply denies the observation of molten iron in the rock. I call this the longest smoking gun in history because it took the New York Fire Department 3 months to put out the fires on ground zero. And they tried everything. They poured millions of gallons of water on the site, and the Hudson River was nearby. They applied a synthetic fire depressant called pyrocool to put that. They simply could put a lid on it. There was something going on, and there were strange chemicals coming out of the ground, eruptions on certain days. Another evidence of thermite were observations in the dust. Now we have to focus the rest of my presentation on the dust. Because the preceding, what I'm going to tell you, are some very early reports done by a private company called the RJV Group. Already in December 2003 and 2004, they published a report on the dust where they described the dust, the findings of the dust, the compositions of the dust, the particles found in the dust. And among other things, they found an occurrence of some small iron spheres, balls, which I'll show you in a little while, but in a content of 5.87%, which is roughly 130, 140 times more than you should expect in ordinary office dust. Same observations was made by the US Geological Survey about a year or two afterwards. And because of these reports, in which there were many other observations, which unambitiously implied the occurrence of extremely high temperatures during the collapse of the fire. Yes, please?
What temperature can commercial jet fuel achieve?
Oh, the jet fuel. Okay, let's take the jet fuel. Right, the very, very first videos I showed you, you saw the impact of the airliner, and you saw a huge fireball outside the building. That's where the jet fuel went. Outside the building. Maybe 95%. Of course, a little fraction of the jet fuel went with the airliner into the building and started the fires that we saw. But no expert expected any jet fuel to be there after 5, 6, 7 minutes. This is the time what it would take for the jet fuel to be consumed after the impact, whatever was in the building. And jet fuel is not burning particularly hot. It's like kerosene. So this is an ordinary, what we call a hydrocarbon fire, a diffused hydrocarbon fire. And temperatures reached under these circumstances are maybe 600, 650 degrees centigrade. It is not particularly hot. And no official account or semi-official account are relying on the jet fuel as a source of anything. It was only something which came up in the media very, very long. There's no way the jet fuel played a role except for initiating the early fires in the towers.
What temperature does iron melt at?
1538 degrees centigrade. Now, I should tell you the story of an American scientist called Stephen A. Jones, who read these reports I just told you about, and the preliminary findings in the dust. There was a woman called Janet McKinley, who lived on the corner of Liberty Street and Cedar Street, here on this corner. She actually had a view of the plaza. And when the South Tower fell, which was the tower which came down first, she took a wet towel, ran it around her face, and ran away. Very clever, because the dust is not very healthy to breathe. And she was allowed to come back to her apartment about a week later, and it looked like this. The windows were completely blown out. So she had quite a cleaning job to do. She had a spirit, I must say, I'm saying she had a spiritual mind because she passed away a few months ago from a brain tumor. But she had a very spiritual connection with this dust, and she understood the significance of the event. She saved some of the dust in a plastic bag, having the intention of making it into a piece of artwork later on. So accidentally, Stephen A. Jones, this American scientist from Brigham Young University in Utah, got in connection with Janet McKinley because he wanted to look into the dust. When you have an explosive event, there's always something left. And he had, due to these early reports and these implications of very high temperatures, he wanted to take a look at the dust himself. And the first sample he got was from Janet McKinley. He put it under an electron microscope. And this is the peak that you see up here to your left. Most of the dust had irregular shapes of what you would expect from pulverized concrete. But some of the particles are perfectly round. And if you take a plastic bag of the dust and a very strong magnet, and you pull the magnet along the plastic bag, something comes along. And you all know if something comes along, a magnet, it's because it can become magnetic, because there's iron in it. Because what comes along is, to a very large extent, these perfectly round spheres. And here you see the spheres in a close-up. It's iron. Now, how come? Well, maybe I should show you then an experiment that Stephen A. Jones then did with the commercial diamond. You can buy Thermite if you wish and play around with it in your background. I would not suggest it. Please remember to put on Google's detective. And but he did this in the corner of the lab, and you will see this sputtering, very violent reaction as we observed on the French fire. And after the reaction was over, he collected the dust which inevitably fell around this reaction site, and it looked like the picture to the left. So this is what you get from reacting an ordinary thermite, and this is the picture I just showed you from the WTC dust. Now, how could we know how that this is exactly the same material making these spheres here and here? We are applying a technology called energy dispersive spectroscopy, which means that you direct a beam of electrons at a specific site on these particles. And we can do this with an accuracy better than 1/10,000th of a millimeter, 100 nanometers. We can point our electron beam at a specific spot. Now the material responds by sending out X-rays. And this X-rays coming out can be analyzed. And the spectrum looks like this. So each line is characteristic of a specific element. Fe means iron, Ca means calcium, K means potassium, Si for silicon, Al for aluminum, magnesium, sodium, iron, another iron line. And what you see from the World Trade Center dust, the same lines You see iron here, calcium, potassium, silicon, aluminum, magnesium, and iron. There also is a little sulfur peak here in the dust, from the dust, and this is a contamination from wallboard, which is calcium sulfate. There's sulfur in wallboard, bound to the sulfate. And many of the gentlemen here probably knows that wallboard is a wonderful material we can use for, you can put spikes in it, and the whole center of the towers were covered with wallboard, gypsum. It's a very efficient fireproofing material. So this is simply contamination from wallboard. Now, the important point here is what possibly can make an iron particle so perfectly round. The only explanation is that this particle has been molten and it has been upflying. It is a property of droplets. They are, by nature, completely round due to an effect called surface tension. So if you have a close-up look of, say, ordinary fog in a microscope, or the small fat pearls in your skim milk, you will observe that they're completely round. So this iron particle here has been offline, and there's no doubt that this is from the thermite reaction.
Sorry.
Yes, please.
Are you saying up flying?
Yeah, it's flying in the air. Okay, this is, it has to be when it's not.
Are you familiar with the Big Bang Theory?
No.
When an asteroid hit the Earth and then humanity started?
Well, Big Bang occurred for 13.8 billion years ago.
Is it possible the airplane hits and the aluminum in there mixed with the dust?
Oh, now I get your point. This is a question I get very, very frequently, because thermite, maybe I remember it, but I'll just tell you actually what we found in the dust. Because Stephen A. Jones also asked himself the question. As I said, whenever you use an explosive, there's always something left. So maybe if we look carefully, we could find remains of thermite in the dust. And he did indeed find this. He should give the credit for having been thinking on this and actually doing the initial experiments. And this was presented on December the 15th in Boston. And when Jones showed this picture, we call them red-gray chips. They're tiny particles being red on one side, and you'll recognize that it is the same color as rust. It is indeed, because it contains iron oxide. The other side is gray, and it's another variety of iron oxide. It's not important. And this particularly red-gray chips is extraordinarily big. It's about almost 2 millimeters. And the thickness of these red-gray chips are on the order of magnitude about 1/10 of a millimeter across here. This is an electron microscope picture of a chip, and there are no colors in an electron microscope. So I had to inform you that this is the red layer, and this is the gray layer. Most of them are less than 1 millimeter. So you need a microscope to find them, and also some skill of experience also to pick out the chips. Some of the chips we have discovered were reactive. And before I go through the highlights, let me mention that the work eventually led to a scientific publication which came out on April 3rd, 2009, almost 2 years ago, where yours sincerely had the honor of being on a team of 9 scientists of publishing these findings. And this will be the last time on my presentation to go through the highlights of this. The most important property of the red-gray chips are that they are reactive. There's some of them, you have to pick one. Some of them are reactive, meaning that they take off when you heat them up. It's rather difficult actually to show, to illustrate